Hope's rule, evolutionary trend towards larger body size. Hi guys, in this anthropology lecture, let us discuss one rule in evolutionary biology. Hope's rule. Hope's rule, it states that populations during the course of evolution, tend to increase their body size until nature imposes a restriction on such increase in body size. What is the need for population to increase their body size? For example, carnivores. Carnivores are inside a jungle are known for interspecies fighting. There is always a competition for food. So there is a need for a carnivore to increase their body size so that they can outpower other small carnivores. Even human beings during the course of evolution increased in size. Australopithecus were just two-thirds the size of modern human beings. Increase in size gave us a lot of comfort. But is this common for all the organisms? Let's discuss that. So Cope's rule, this rule was named after the American paleontologist Edward Drinker Cope. But it was later Charles Depard who hypothesized this concept. That's why we call it as Cope-Depard rule. Evolutionary trend towards larger body size. This rule states that population during the course of evolution tends to increase their body size, but not indefinitely until nature imposes a restriction on such a size increase. There are a number of evidences available in the form of fossils. The best known example is the evolution of horse. The fossil remains of horses shows very clearly that there was a tendency of increase in size in the course of evolution. 50 million years ago, if you have a look at the fossil of a horse, it was at the size of a dog. In the course of evolution, gradually it managed to increase its body weight, and now it had reached its present shape and size. Same is the case with the dinosaurs. So there are many organisms which tend to increase their body size in the course of evolution. So what purpose it is going to serve? As I told you, there is a need for organisms to increase their body size, but that is not the case. But that was not the need for every single organism. For example, small rats which lives in furrows. If they increase their body size, then it will be difficult for them to dig a big furrow and live inside that. So we cannot expect a tendency of increase in body size among the rodents. Same is the case with birds and even bats. With increase in body size, their ability to fly will come down. So we cannot find a trend of increase in body size during the course of evolution among few animals. But there are evidences to show that there were few mammals, few animals which increased their body size in the course of evolution. As I told you, um, this growth in size of the organism is not indefinite. Certainly there is a restriction. Until the environment imposes such a restriction, we can see this evolutionary trend. One very good example to show here is size of a tiger. Tiger, we know what a powerful carnivore it is. So in the course of evolution, a tiger have become larger, and now it's a very large animal. And now it's a very large size of the animal, which is a very big threat for its survival. We all know hunting for a tiger is not that easy. We won in a 10 attempt, maybe a successful attempt. To make that attempt, it need to run fast, spend all the energy. Most of the energy will get drained. And once when a hunting attempt of a tiger fails, it will lose almost all the energy and it will take time for it to regain the energy to think about continuing its work. Apart from that, there are a number of other issues like the alarm calls given by birds and monkeys. Once when a tiger moves in your territory, if the birds after sighting it, it will give an alarm call. Sensing this, monkeys if they look at it, monkeys will give alarm call. And once when there's an alarm call, most of the tigers will not even think about hunting because once when the herbivores are alerted, it will be very difficult for a tiger to go and hunt. So during the course of evolution, the size of the tiger increased, and it had reached a particular stage. And now, the very big size of the tiger gives a threat. It's a very big threat for the animal. So the Cope's law states that organisms during the course of evolution tend to increase in size until nature imposes a restriction on such a size increase. Remember, this law again does not have universal applicability. There are few organisms which do not tend to increase in size during the course of evolution. So there are a number of other rules in evolutionary biology like parallelism, convergence, adaptive radiation, mosaic evolution, parallelism. These we'll be discussing in our subsequent lectures. Thank you. I hope you are comfortable with Cope's law now, Cope's rule.